Hi, welcome to the last lecture of the series. So, in this lecture, we will learn how we can test for mean when the population standard deviation is not known. So, whenever we don't know about the population standard deviation, we use the t-test to approximate the population standard deviation using the sample standard deviation. To do this kind of a test, we refer to the R function t.test. So, just like before, let me open Art Studio. So for this example, we assume that the IQ in a certain population is normally distributed with a mean of 100 and it has an unknown standard deviation. That is, the population standard deviation is not given to us. Now, a scientist wants to know if a new medication affects the IQ levels. So she recruits 20 patients to use it for 1 month and records the IQ levels at the end of the month. Now the IQ of the 20 patients are given herewith. To do this, we will use the function called t.test. But before even doing this test, first we have to enter this data. So I will use a data set, name this data set as IQ and use a C function to input this data set. So I will enter this data set and rename this as IQ. So we have this IQ of 20 patients over here. Now we will be performing the t-test. Since the population standard deviation is not given to us, so we will use the t-test. Now for this t-test, we have t.test and we have the first argument that we have is x over here, that is the name of the data set, that is IQ. Now against what we are testing? We are testing against the value of mu, this is equal to 100. And suppose we want to construct a 95% confidence interval. So we can write the confidence level equal to 0.95. For this example, since the scientist wants to know if a new medication affects the IQ levels, so basically we are testing for two-sided hypothesis. So the alternative hypothesis over here should be two-sided. In z.test or t.test, the default hypothesis that we test is a two-sided test. However, if you want, you can also rewrite that. So you can write alternative, this is equals to two-dot-sided. Remember, if you write less, greater, or two-dot-sided, it should always be entered within quotation marks. Now, if we hit enter, we get a one sample t-test. The test statistics. So over here we have a t-based test statistics. The t-test statistics is 1.5976. We have a degrees of freedom is 19. The degrees of freedom is calculated as 1 minus a sample size. So 20 minus 1 gives the degrees of freedom to be 19. We have a p-value of 0.1266. So if we compare the p-value with respect to any alpha of 1%, 5%, or 10%, we can conclude that the p-value is better than alpha. Hence, we cannot reject the null hypothesis. That is, the IQ level of the students is not different from 100. So alternative hypothesis clearly stated over here that the true mean is not equal to 100, and we have this 95% confidence interval which ranges from 99.05 to 107.05. And in this example, the value of your x bar, that is the sample estimate of your mean, this is equal to 103.05. Now, if the question was a little different, if it was asking that the scientist wants to know if this new medication decreases the IQ level, suppose the question was a little bit different. Suppose the hypothesis was scientist wants to know if the IQ level was less than 100. In that case, everything should have been the same. Only thing that should have changed is the alternative. So instead of this alternative to be two-sided, we could have written this to be less. Now if we hit enter, it gives a t-test where the alternative hypothesis true mean is less than 100. And over here we have a very high p-value. The p-value over here is 0.9367. So in this case as well, we can say that the alternative hypothesis So the null hypothesis is not rejected at any level of significance, at even at 5%, 10%, or 1% level of significance. So we use the t-based test or the t-test in R when the population standard deviation is not known to us. Okay, that's all we have for today's lecture. Thank you all.